All righty. Awesome. So welcome Dr. Estelle Sandhaus to our spring speaker series. We're very excited to have you speak on the condor nesting research and maintenance that is currently going on. And then I know that, oh, sorry, the transcripts are new for me. So, so I got just a little distracted there. My name is Genoa. I am the engagement intern, of course, for the research station. We have Russell Bradley here, our director. So I'll let him introduce himself a little bit and then we'll pass things back over to you. Okay, Estelle?
Sounds great.
Sure. Great. Hi, Estelle. Thanks so much for doing this for us. Thank you, everybody, for attending and those watching the recording. Yeah, we are the Sandhaus Island Research Station. We have this unique student committee and have these, events every 2 weeks, and really think it's a great opportunity for folks to learn more about the islands and various coastal issues. And we have many more of these talks available on our YouTube channel, which you can find if you go to our website. So thanks to Genoa for all your great work in setting this up. And we're excited to see the talk today.
All right, with that, Estelle, I'm gonna go ahead and let you take over. I'm very excited to hear what you have to say tonight. Thanks for being here.
Oh, thank you all so much for having me here. It's so great to get a chance to be part of this awesome speaker series and a chance to speak with you all. I hope we'll have a chance to do maybe some Q&A at the end. Yeah, just to start, I'm Estelle Sandhaus, and today I'm going to talk about California condor conservation and research, all within the context of the recovery program. Okay, there we go. So I know we have, students in our audience, so I thought I would just spend a brief moment to share a little bit about my career path. I did my undergraduate work at University of California, San Diego. And, just a point here, I started out in physiology and neuroscience as a pre-vet, and I took a lot of upper division biology elective courses that were just interesting. And that led me down a different path. So I really encourage you all to, explore what interests you, of course, within the context of, your schedule and whatnot. But it led me into quite an interest in behavioral ecology and animal behavior. And from there, I started volunteering at the San Diego Zoo's, at the time, Center for Reproduction of Endangered Species. Now it's the Beckman Center Institution for Conservation Research. And I was volunteering on a giant panda behavioral research project. And we were so fortunate to have the chance to study a pair of giant pandas that were in the US and had the first offspring to survive in the US long-term, Hua Mei, whose beautiful face is on that screen. And so we were studying social development and environmental enrichment, olfactory communication, so all kinds of really interesting things. And I really just became enamored with the study of behavior and, wrestling with, how do you quantify some of these measures that, maybe aren't as clear cut as, physiology, blood lead levels. And from there, I went to Georgia Tech into the PhD program for animal behavior. And we had a really neat program there that was a collaboration between Zoo Atlanta and Georgia Tech. And so I was able to continue studying pandas and do some work at the giant panda research base of giant panda breeding in Chengdu, China. And then from there, I came to the Santa Barbara Zoo, which was such an incredible opportunity. I think, as you all know, we live in this location with so many natural resources. We're surrounded by, Channel Islands National Marine Sanctuary, Channel Islands National Park. I don't have to tell this group that. We have wilderness areas, national forests. And so the zoo, we've really chosen to focus our conservation efforts on this region. And being so close, we're able to involve people from all of our different departments at the zoo in on-the-ground field conservation. So whether it's our facilities department coming out and helping build a flight pen for condors, our education folks helping with signage in the Los Padres National Forest, of course, our animal care staff helping with fox transects on the islands, and then of course bring all of this back to tell stories to our guests. We have maybe close to 500,000 visits a year. And so we can share these stories firsthand. And also at the zoo, I mean, you can gaze out, from our zoo hilltop, and you can see the National Marine Sanctuary. You can see the Santanez Mountains. So we think that's really salient. And, I think you all are well familiar, but, here, a significant portion of California, but also where we live is a designated Conservation International biodiversity hotspot. It's also a WWF Global 200 ecoregion. And so, we are just very committed to conserving the important biodiversity in this area, which includes the California condor. And so today, just an overview of this talk. I'm going to briefly touch on the natural history elements that are most relevant to the conservation research I'll be discussing today, a little bit about the decline, and then the recovery in 4 phases: rescue, captive breeding, reintroduction, and sustainability. And we will spend only a brief time in the first 3 phases and really dig into the sustainability phase, which is where we're at now in the program. First, I do want to acknowledge some of the many partners working on behalf of condor conservation and research. All of this is interdisciplinary and partnerships. And so, we have our federal agencies, our state agencies, multiple governments, universities, other NGOs, and of course the zoos. So this is all a team effort. And that's another key about conservation is it takes many different organizations and disciplines to make it happen. So some just basic natural history highlights that will put what we're going to talk about in context. The condor is a cathartic vulture. It's case selected, so it's long-lived. It's slow to reach sexual maturity. It has a slow reproductive rate. And so that's something to keep in mind when we talk about the time frame of the recovery program. So you look at an animal like the island fox that matures rapidly and has multiple cubs each year. That animal is capable of recovering, just by virtue of numbers more quickly, just by virtue of its life strategy. And so the condor is a little more like a marathon if you compare it maybe to a human lifespan. So that's something to keep in mind. The current age of oldest specimen with known birth date is about 54 years old. And I say about because I have to keep updating my talk that condor, he is just going and going and going, and he's still reproductively active. We don't know the upper limit on age, maybe 60, 70 years perhaps, and that's just based on similar species, but we don't know yet. They do roost and feed communally. It's primarily a soaring bird, and they can travel 225 kilometers in a day when they're foraging. They mainly feed on large mammals, although they did appear to rely more on small mammals perhaps in the historic population. They're an obligate scavenger, and they can consume about 3 to 4 pounds at a feeding. They do nest singly in dispersed territories. And for foraging, they seek primarily open habitats such as savanna woodland for foraging. And these photos are at Bitter Creek National Wildlife Refuge. Now, as far as nesting, they select generally areas with high snags or cliff faces, natural cavities in cliffs or giant sequoias or redwoods. Sometimes they might even lay an egg on a little outcrop or ledge on the side of a cliff. They had generally been thought to raise 1 chick approximately every other year, but what we're finding, and I'll talk more about that later, is that nesting in consecutive years does occur. And they were once, like many species, thought to be monogamous, but extra pair copulation is pretty well documented now in the reintroduced population. Now, as far as nests, just so you have a picture of what a condor nest is, here is a picture of one nesting, well, a slice of a nesting territory. So this is really what one pair will call home. And those 2 arrows point to different cavities within that territory. And a pair will usually kind of bounce around within different cavities among different years. And this is a zoomed in view, and you can see a little bit closer these cavities. And one thing that often surprises people, maybe not biology students, but condors don't, build nests in maybe what you would consider the traditional sense. They lay an egg in the substrate, and they do manicure the substrate while they're brooding the egg and whatnot, but it's just generally laid in the substrate. There was one instance that I'm aware of in the Baja population where a condor laid an egg in a golden eagle nest, and everyone got a big kick out of that. But that's not typical. So condor egg, just laid in substrate. Now, the decline. I'll briefly highlight some of these points about the decline and recovery. I know some of you are probably pretty familiar with this. For a deep dive into the natural history of the species and early recovery program, I would encourage you to check out, it's out of print now, but you can still, get it in the library or Amazon. There's like out of print. I'm probably not supposed to advertise a given, bookstore, but, you could get it online, an old copy, but Snyder and Snyder's California Condor, a saga of natural history and conservation. And it's a nice mix of, the history of the program and the biology. And I also recommend Coford's report, Audubon report, which is also out of print, but you can dig up as well. But both have a lot of great information. And I'll be pulling from that for these highlights. So, the condor once ranged over much of the southern United States, south to Nuevo Leon, Mexico, east of Florida, as well as upstate New York. Yes, Dorothy, remind me to do that at the end of the talk, and I will put those book names in the chat. So during the Pleistocene, condors fed on both terrestrial megafauna and marine mammals. And the disappearance of the condor from much of this range occurred about 10 to 11,000 years ago. And though early historical accounts reported condors feeding on carcasses of marine mammals, by the late 1700s, condor diets had shifted predominantly to terrestrial animals. And this followed the commercial harvesting of marine mammals and the development of cattle ranching on land. And this kind of allowed them to shift eastward. There was a severe decline, though, in the 20th century. Not an issue with breeding, but we had shooting, egg collecting, power of coal collisions. The scientific consensus now is really that lead poisoning was the key factor in this. And we will talk quite a bit about lead poisoning later. Now, in the 80s, further drastic decline, and by 1984, the world population was just 22 birds. When you're that low, you don't often know whether you're below the effective population size. You don't know whether a population is recoverable. So this was a very, very dire situation. We'll return to this image later, though. But yeah, if you check out this 1980s range, this is this black horseshoe. So the first phase of condor recovery is rescue. There are 22 birds in the world. What are we going to do? Well, the controversial decision, and those who were there could probably give a talk solely about this, was made to pull the remaining condors in for captive breeding at San Diego Zoo Safari Park and Los Angeles Zoo. And there were philosophical discussions, would condors reared in captivity still be condors? What does it mean for no condors to be flying in the skies again? And there were practical discussions, would captive breeding be successful? Could the program successfully reintegrate these condors into an environment that was completely devoid of other members of their species? And, these were questions that no one had definite answers to. So it was, a very tenuous time. But in 1987, the last remaining wild condor, known as AC8 or adult condor 8, was captured, and this new era started where the California condor no longer soared anywhere, extinct in the wild, and that's really just one step over from extinction. So a very grim situation, but I think the first step that needed to be taken to save this species. So the next phase, captive breeding, did overlap a little bit with rescue. The zoos were working with the service on, getting stuff ready. So it's not a hard stop between those eras. But, many of you have probably seen those famous images of captive propagation of the condors in those early years. And initially, the goal was rapid reproduction. They needed to breed really as many individuals as quickly as possible to retain that genetic diversity in that small number of birds. There were 14 founders. And so, here you have artificial incubation on most of the eggs and puppet rearing as well. Later, as the population was a bit more secure and the genetics were sort of safely banked, they were able to start moving a little bit more to parent rearing. But early on, it was really about that rapid reproduction. And I came across this old news release from 1988, and aside from the kind of funny font and everything, it really was striking to me that this was a celebration of a key milestone in this phase of recovery. It was the hatching the world's first captive bred condor at the San Diego Wild Animal Park. And I can only imagine the relief that these folks felt because the entire fate of this entire species was on their shoulders. And for some of my dissertation work, I was able to go through the keeper logs because I was looking at early rearing variables, developmental variables. And, you could read the accounts of the keepers day by day, and just each of these condors was so precious, and not only as an individual, but for the fate of the species. So, we have much thanks to give to all of the folks in the program in those early days. Fortunately, captive breeding was very successful. And so the program was able to move to this next phase, which was reintroduction. And this began in 1992. And this does overlap with where we're at now. Reintroductions are still happening, and we'll talk about that later. This is the current-ish range map of reintroduced populations. There are release sites in Southern California, Central California, Baja California, Mexico, and Northern Arizona. And of these release areas, each is operated by a different program partner or partners. There's a variety of landscapes, habitats, and it really demonstrates that this is a generalist bird. It can exploit a variety of habitats. And very soon, these sites will be joined by a fifth flock in Northern California on Yurok ancestral territory. This is a long-awaited milestone, and the condors that are slated for release are currently being cared for by the Montana Wildlife Society, and they can actually be observed on an explore.org live cam, and will be released in the coming weeks. So that is really exciting, and that might be another link I can dig for you and put in the chat. Now, condors, you may have seen photos of the early years when people were carrying, what probably literally are dog kennels, but kennels with condors inside, and, release the door and let them out. Condors are still released from kennels, but in that case now it's usually very experienced condors who might have been in captivity for medical treatment. But the release strategy has really changed over the years. Condors are now held for a longer period of time in larger field pens with adult mentor birds to improve their survival skills. They have items in the pens like mock power poles that have a mild electrical current to deter them, to teach them not to land on power poles. So release strategies have really gone from a kind of what we would refer to as a hard strategy to a soft strategy. Releases are gradual. So, we have a double door trap. You can see this little, well, it's behind this little blind that people sit in, but we will open the trap door and the condors leave as they feel comfortable. So they can go back into the pen if they like. So it's much more gentle. And then biologists are also supporting the condors if needed with supplemental feeding for a period of weeks, tracking them. I will say that now that there are more condors out there, the demographics of the released population has changed. There are groups of youngsters flying around and socializing together. The releases are a little bit smoother in that I think the biologists have less to do because these guys really integrate with the other youngsters in the flock and kind of do their thing. But since the reintroduction efforts began, range expansion and population growth have largely been sustained through ongoing captive releases and intensive population management. And these are made necessary by ongoing anthropogenic threats. Lead poisoning from ingestion of spent ammunition is still the leading source of mortality in all wild flocks. I'll talk that a little bit more in the sustainability portion of my talk. But these birds are generally every bird wears an identification tag, VHF transmitters that are attached to their tail feathers. About 85% of the Southern California population carries GPS transmitters on their wings. The other flocks do carry GPS as well. We do health checks twice a year when we're able to trap them. So it's a very intensive program. So this kind of brings us to this last phase of recovery, which is population sustainability. So when we're talking about condor recovery, to be downlisted, essentially we need 3 condor populations that are distinct, and 2 are disjunct and wild, and then 1 will be an assurance population in captivity. And there's a set number of breeding pairs for each of these populations, and there's a criterion that it has to be self-sustainable. So they have to be breeding and replacing mortalities in order, to continue population stability and growth. And so again, right now, we are augmenting the population. So it is not yet sustainable on its own. Now in SoCal, so one of the focuses that our group has been working on is nesting. And we had a real challenge in the first years of nesting in 01 to 06. Colleagues at San Diego Zoo, U.S. Fish and Wildlife Service, LA Zoo, determined that wild nests were falling far short of the productivity needed for positive growth. So they would have needed 50% success to replace mortalities that occurred in that time period. This was also not comparable to nest success in the remnant population of the 80s or the Arizona reintroduced population during that same time period. So you see we have this 6 to 12% in Southern California. It is abnormally low. And failures were attributed to a variety of causes, such as predation, chicken egg abnormalities, uncoordinated pair exchanges. But the main factor in Southern California for nest failure was nestling ingestion of microtrash. You'll also see in the literature referred to as junk, but it's small items like pop tops, bottle caps, pieces of glass, trash. Yes, Dorothy, trash. And it was present in 82% of chicks examined. And so you can see this top left picture. This is trash that was actually removed from a chick at LA Zoo. And I do want to address though, when we're talking about behavior of these or any other, animal species, this image to the right, it shows one site where the condors were picking up trash. And so it's basically an area in the national forest. Some of these are areas surrounding telecommunications towers or roadside pullouts or berms along forest roads. But what they have in common is they are in condor habitat and they're being impacted by human presence. And it's not the human presence alone that's a problem, but it's some of these human behaviors that are leaving trash behind. So condors are behaving essentially as they always had, but in a rapidly changed environment. So you may be learning in your classes about human-induced rapid environmental change and ecological traps. And this is likely, what we're seeing is an ecological trap for condors, because for condors, it's typical for them to seek out and collect pieces of bone and shell to feed their nestlings. Unfortunately, in place of bone, here we have items of trash, and we suspect that they can't discriminate between the two. So, it's a human dimensions issue rather than, a strictly biological issue. So in 2006, mid-season, 3 of 4 nests had failed. And the service was really determined that the final chick of the season would fledge. And so this was actually when I started, when I came to Santa Barbara and started getting involved with the program. And so the team was doing dawn to dusk observations of all of the nests from blinds and was ready to intervene if there were issues with this chick. And so a number of interventions were undertaken, removing trash from the nest, removing trash from the chick's crop actually in the nest. And then ultimately when this chick had a trash impaction, removing the chick from the nest, having a biologist spend the night in the nest out of extreme caution that the condors would not discover an empty nest and abandon it. And we have more data about that type of circumstance now. Condors will, it would be, I think, unlikely for that to happen. But a biologist did spend the night in the nest. The chick had surgery at Los Angeles Zoo, was helicoptered back in the nest. And you know, I was fortunate to get to observe this. The parents immediately resumed care. And they're, you know, just incredibly doting parents. And this chick fledged. And so this was quite a success. And based on this, and also based on some precedent for successful nest guarding in other species like the Puerto Rican parrot, we worked with Fish and Wildlife Service and Los Angeles Zoo to design a systematic nest guarding program to implement across the entire nesting population in Southern California from that point forward. And this intensive management program had a two-pronged approach. So the first prong is behavioral observations from a distant blind and later streaming video, which allow us to monitor the chicks' development as well as ask important research questions. And just a note here that community science was part of this. We recruited and trained citizen or community volunteers from all walks of life to help us. You know, we were aiming to observe these nests in our first regime of about 5 years for 40% of daylight hours. And, you know, when you have 13-hour days in the summer, that is a lot of hours. So we owe a lot to our very dedicated community volunteers. Now, we also, in addition to those behavioral observations, had a systematic scheduled nest entries. And prior to this program, nest entries had really been reactionary, you know, in response to problems. And so we were lacking data about when was the trash exactly being brought to the nest, how much trash was in the nest, when were these critical time periods. And so we had a systematic schedule of nest entries at 30, 60, 90, 120 days. And we would measure trash, supplement some nests with bone fragments, measure the chick growth, draw blood, etc. And then the second prong of this program involved interventions to address any number of threats to success that are ongoing or uncovered through these observations or nest entries. So examples include removing microtrash from the substrate during nest entries, whether routine or not, to reduce the overall trash burden, removing chicks for medical treatment for microtrash impaction, and then returning them to the nest, potentially treating chicks in the nest for lead poisoning. And so that was sort of this approach. This allowed us to get unprecedented data on nesting behavior of wild condors, which allows us not only to manage the population more effectively, but provide more insight in the natural history of the condor that had not previously been reported in the wild populations, you know, partly because they did not have the capacity to observe or the technology to observe as intensively as we did. So for instance, you know, we've been able to determine what typical attendance and socialization patterns are for these birds. You know, we got a call from a neighboring site. Hey, you know, we've got a dead parent member. We're trying to figure out how long, you know, a bird can be away from the nest, what's typical. Well, you know, you can kind of look at these curves and determine, you know, how much flex you have with only one parent. As another example, you know, we've observed instances of successful trio nesting and also of, you know, these single parents managing to fledge chicks after the death of their mate during the chick phase. Now, because of our intensive nesting management in Southern California, we've also been able to work with colleagues to answer other questions, such as questions in Central California to understand more about threats to success in their population. And so in particular, from 07 to 09, hatch success in Central California was only 20 to 40%. So that was significantly lower than 70 to 80% that we had at the same time in Southern California. And because we were entering nests routinely, we were able to compare eggshell fragments collected from our nests with their nests and compare mean thickness. And the mean thickness of the fragments up there were 34% lower than the mean thickness of the fragments recovered down here in successful nests. And what you can see in this electron micrograph is basically on this left side, it's missing the outer crystalline layer of the eggshell. And what that does is it results in increased water loss. And so Why is this happening? And because of this water loss, basically, the eggs are more fragile and they can get crushed and not hatched. And so basically, you may be well aware as conservationists that DDT and DDE from waste of a DDT factory discharged in the Southern California Bight had previously caused extensive eggshell thinning and reproductive failure in fish-eating and raptorial birds like the bald eagle on the Channel Islands. So what's really interesting is the Central California condors had begun to feed on marine mammals after a period of time, whereas in Southern California, we have almost a control population that is not feeding on marine mammals. And so we were able to conclude that this marine diet essentially is associated with the thinning. Now, like that of other species affected previously by DDE, the expectation is that this thickness issue is going to resolve over time, and we're working on some follow-up paper for this. So stay tuned for more news on that front. Now, the I think big question about nest management is, does nest guarding work? And the answer is absolutely, it does. We were able to maintain nest success over 53% over the life of the program, which is well above the historical and recent historical baseline, and even more above that initial 6 to 12%. And I do think it's worth pointing out that we have several guarding regimes over the years that have become less and less intensive, so that you may see a reflection on that. We've been doing not any egg management in the last 4 or so years, so potentially less success in these less intensive regimes, but guarding does work. And as far as a perspective of what this means for the overall Southern California population, again, let's go back to the early days of recovery in rescue, when we had no idea whether captive breeding would work, whether reintroduction would work. Would these birds retain the behavioral traits that they needed to survive and flourish? Well, here we have 1992 to 2019. The dark green is captive reared birds in the Southern California population, and this light green wedge is wild fledged chicks. And so what you can observe now is that about a quarter of the population in Southern California is now wild fledged. So, we have condors that are roosting and nesting in historic areas. They are nesting in historic cavities that previous birds in the historical population used, and they are successfully fledging chicks. So this is very exciting. Now, I promised we would talk more about lead as a factor of mortality. And so this is a chart of causes of known deaths in the condor population, so the whole wild condor population between 92 and 2020. And 50% of the deaths with a known cause are lead poisoning. So this is the reason that we are having mortalities that are outpacing reproduction. So how does lead poisoning typically happen in condors? And I get this question a lot when I'm talking in the community. So, as we discussed, condors are scavengers, and they are scavenging, sometimes unpredictably in space and time, opportunistically. They're feeding primarily on carcasses of large mammals such as deer. And in doing so, they can ingest fragments of lead bullets from feeding on either carcasses or gut piles of animals that have been shot. And I really want to emphasize that the challenge here is not hunting, it is not shooting, but it's specifically lead ammunition. Most lead core rifle bullets fragment into hundreds of tiny pieces when they strike animal tissue. And so you can see a demonstration of this. On the left, you have a comparison. So this left image, you have a comparison of discharged lead and non-lead bullets. So here's the lead with the fragments, and then you have this non-lead bullet where it retained its weight. And then another way to look at this is firing ammunition into ballistic gelatin and x-raying it. And you can see the non-lead pathways versus the lead pathway. And you can see all of these fragments that would be along and beyond the wound channel in an animal that was left in the field. So again, the challenge isn't the carcass, it's not the gut piles. Regulated sustainable hunting can really enhance condor recovery by providing a source of food. The issue here is lead, which is toxic to condors and other scavengers. And, you know, for an image of what this looks like in a condor, here's a radiograph of condor 318 with fragments in their digestive tract. And you have this pull-out photo here of the actual lead fragment that was recovered from the bird. Sadly, this bird died from lead poisoning in 2012. Now, as biologists or students of conservation will think, okay, you know, what does this mean specifically for condors? And, you know, one thing to keep in mind, they feed together communally. And so because of their feeding ecology, the impacts of a single lead contaminated carcass with all of those fragments can be very substantial and affect many individuals in a single feeding event. So at this time, ongoing intensive management of the population is ameliorating the population effects of mortality due to lead poisoning. And in order to achieve recovery, we have to eliminate or substantially reduce lead poisoning rates in the population. I did want to touch a little bit, this is related to our nest work, but it's also a question that had come up regarding lead poisoning. Another aspect that nest management enabled us to study is the question of whether condors might have lead exposure risk from trash ingestion. And because we were, you know, doing our intensive nest management, we collected trash from condor nest areas and nestlings between 2002 and 2008. We analyzed the items that were suspected to contain sufficient lead to be of toxicologic concern. So 27 of these 71 items that were leached and analyzed for lead were lead containing, so based on a cutoff of greater than 1 microgram per milliliter. And the majority of those items, 81% of them, were ammunition related. So that would include spent lead casings, jacketed bullets, things like this. And only 3 of the 1,413 items collected were lead containing, but were clearly not ammunition related. The other 2 lead containing items were unidentified. So our results here suggest that trash ingestion of non-ammunition items doesn't pose a significant lead exposure risk to the population in California. It does suggest that lead exposure through ammunition related items can be a potential pathway, though not a significant one, contributing to this epidemic of lead poisoning. So you may ask, what is being done to limit exposure of condors and other scavengers to spent lead ammunition? And, you know, the thing I think so many people are very familiar with is legislation to limit the use of lead ammo in California. And this is very location and population specific. But talking about California, in 2007, we had the Ridley Tree Condor Preservation Act, which required non-lead for big game and coyotes in a condor zone. And then in 2013, California Assembly Bill 711, which was phased in over 5 years, provided that non-lead be used for all wildlife shooting in California. Even more important, perhaps, though, than legislation is working directly with the community of sports persons. Hunting has a long, rich conservation legacy in the United States. The U.S. Fish and Wildlife Service refuge system was created in 1903 to preserve fishing and waterfowl hunting lands. We know the Pittman-Robertson Act contributes $400 million to $1.6 billion annually to conservation funds. And so I would encourage you all, if you're interested in this issue, check out these websites, huntingwithnonlead.org and the North American Non-Lead Partnership. They have incredible information about hunting with non-lead, the science and practical matters. If there are any hunters in the room or watching this recording and you'd like to know more, please reach out and I will connect you to one of the hunters in the program who can talk to you directly about their experience with non-lead ammunition and you know, just go from there. So there is a lot of great work being done right now to reduce the burden of lead in the environment for condors and other scavengers. But this really gets to the crux, and ongoing condor management, whether it's treatment for lead poisoning or nest management for microtrash, it's a stopgap effort until the human dimensions can be adequately addressed. And I just wanted to put a quick note in here about, one of the programs we're really proud of. In Southern California, the Hopper Mountain National Wildlife Refuge is one of the bases for field operations. It contains and is surrounded by historic condor nesting habitat, and it's just 6 miles from the city of Fillmore. Mountain Vista Elementary School, one of the schools in the Fillmore Unified School District, is just 2 miles from some of our active nesting territories. So, this is a community that shares, basically just shares its life with the condor, and this community is incredibly proud of the condor. And so we've worked together to design, through the Urban Wildlife Refuge Program and some other grants, a program to bring condor-related curriculum into the school district, bring kids out to the refuges, bring them out to the zoo, and all this curriculum is aligned to next generation science standards. So it really met needs for the teachers as well. And these kids are just incredible. I think that a good portion of these kids could probably give a good portion of my talk today. They are so knowledgeable about condors, and it's really exciting. And they bring this knowledge home to their families, and it's just an incredible program. You can go to condorkids.org and learn more about it. This curriculum is free, so anyone can use it. You can use it in community events, pull out pieces of the curriculum. So it's really an incredible program. So where are we now, population-wise? Well, at last assessment, which is 2020, the IUCN designated the condor is still critically endangered, but the population trend is increasing. And so that is absolutely a positive. The condor is, I think, often held up as a success story. It was rescued from the brink of extinction, just 22 individuals. And now we have over 500 birds in the world. Well over half of those are free flying. And they are, their natural history is reflective of what we know of the original populations. And so that is really exciting. And so we just have this final hurdle of excess mortality, really, due to lead poisoning. That is our biggest final hurdle. So I'm very optimistic about that. Now, as you can see, I promised I would bring this image back. You can see this horseshoe. And then here's a recent kernel density estimate image of the Southern California population, and you can see they have filled back in this range, which is super exciting. When I started in 2006, the condors were really here and here. Whoops. So it's just incredible to see this. So these are really bright days. So we just need to get that final piece of self-sustainability in place. We couldn't do what we do without the generous support of many foundations, zoos, corporate sponsors, university partners, and of course, every zoo visit supports our work. Later this season, you all can check out the live stream, if all goes well, of Condor Nest in Southern California. You can access that on our website. We have Southern California nest updates that we work on with the Refuge Complex on the Condor Cave on Facebook. Whether you're on Facebook a lot or not, I highly suggest you check out the cave because the updates are really fun. And then of course we have this great curriculum at condorkids.org. And with that, I would love to open this up for questions.
Hello. Hi, can you hear me? Okay, I have a question. Since there's so little condors, is lack of genetic variation something you guys worry about, and what can you guys do to, like, I guess, increase genetic variation?
Such a good question. Okay, so caveat, genetics is not my expertise. So yes, the population is very carefully managed. And this is actually a great example of the one plan approach in conservation, if you've heard of that. But the entire condor population, whether captive propagation or wild, is genetically managed together. And so each year, geneticists, population biologists sit down with breeding centers, with the field biologists, and determine where eggs are going to go the next year. And this is largely guided by genetics. And so, we have the different field sites and we have the different breeding sites. And so there is a continuous effort to make sure that the different founders are well represented in all of the populations, in all of the wild flocks and in the captive breeding program. So it is aggressively managed to maintain genetic diversity. There have been a number of studies on the genetic diversity, and my understanding is it's considered a pretty healthy population, which when you think 22 birds, that's good news. But we know that a number of species have undergone bottlenecks, sometimes naturally, in their history and recovered from that. So yeah, the answer is it is an ongoing management issue.
Thank you.
I have one or two. Estelle, thanks so much for such a really
Sure.
great talk. I have two, we'll do two. One is this whole UROC reintroduction on tribal lands in the northern part of the state. That's very exciting. I've heard of that before. How many birds are being released up there?
I think to start, okay, I don't remember offhand, but like between 4 and 7 probably to start. So yeah.
Okay, cool. Very, very, very cool. My other question was about the whole supplemental feeding and how that relates to these wild-born chicks. I remember hiring people in my previous work in the Farallones who had worked for, there was, for many years, there were people, the old joke was that you get hired to basically walk around with a backpack in like Arizona or wherever full of, a cow or something to feed to these condors. Is the same level of supplemental feeding required for these wild-born birds as the ones that were captively or were released from captivity?
That is an excellent question. So I think my answer would be that the same level of supplemental feeding is not currently required for captive reared or wild fledged birds. The population is now foraging widely. The Southern California population alone is ranging over about 10,000 square miles, and they are finding their food. We largely in Southern California maintain bait stations to enable us to trap the birds at this time. So, keep them coming back often enough that it's a familiar place to check. And then twice a year, we're able to trap and then health check and transmit to the population. Now, at various times in the program and, potentially in other flocks, the supplemental feeding has been used as a source of lead-free food, known, clean, supplemental food. But currently our population, if you asked my opinion on whether you could force the birds to only eat, provisioned food, I think my answer would be unlikely. They are just, ranging so widely and foraging on their own. So yeah, it's a
Very
great.
cool.
And yes, they're when I first started, I feel that, hiking around with carcasses was still a big part of the job description of the biologist.
Actually, I have a couple quick questions. That you were talking about shell thinning being a problem, and that you said specifically that it was due to the diet of marine food, correct? Or
Okay, wait, sorry. Can you repeat that first part again?
so when you were talking about shell thinning and shell thinning being linked to being caused by the diet and the diet being marine foods, was there a specific reason why these they were eating marine foods? And then also, how come the shell not being able, the egg not being able to absorb water affects hatching as well?
Both really good questions. Okay, so regarding the seafood, seafood, that sounds like kind of a human term. Regarding the marine life, the Big Sur condors, the Central California condors, this was traditionally, well, and other condors as well, this was traditionally a part of their diet. And so really, when they began to feed on marine mammals again, it was really just seen as, okay, they're starting to more fully inhabit their full ecological niche, right? It was, sort of expected. And I remember when they fed on the first gray whale that had washed up in Montana, and it was just amazing because, condors hadn't fed on a gray whale or a whale since it might have been, I don't know if it was a gray whale with Lewis and Clark, but it was the days of Lewis and Clark that they had last observed condors feeding on a whale. And so it was so incredibly exciting. And, at first I think, at least some of us were like, oh, great, that's relative, less risk of lead poisoning. But then when you have the California sea lions, there's a lot of bioaccumulation of things like, potentially mercury. And of course, you have the DDT, DDE issue. So condors feeding on marine animals is an expected part of their biology. Now in Southern California, we're so far south, there don't seem to be, in my recollection, historical records of them foraging along the beaches down here. So it may be that if our birds are remaining down here, we won't see that. What I did forget to say was when I was talking about the two separate wild populations, one of those is expected to eventually be all along that western coast, and it will be distinct from that southwestern United States population. And so we have some mixing between the Southern California and Central California birds now, but it's not a lot. But we may see more of that in the future. And then the same with the Baja birds. Ultimately that's, expected that may be one contiguous population. So that'll be interesting too. We have birds who specialize in certain areas for foraging. As far as the water loss, this also is not my area of expertise, incubating eggs. And, the folks at the zoos are incredible at this. I know when they incubate the captive eggs, one of the things that they're controlling very tightly in the incubators is humidity. You need the right rate of water loss for the health of the embryo. And, maybe Allison or anyone else who wants to jump in here, but you need a certain range of water loss for that egg to have integrity and for the chick to hatch. And so if it's excessive, that's where the egg gets, fragile and then is literally sometimes crushed under the birds. And so that's what was happening. Did that kind of answer?
No, yeah, definitely. I also had another quick question. Sorry, but
yeah, no. I wanted to. I was hoping people would have questions.
I think you talked about it slightly, but is there any fear of the risk of impacting the natural behaviors of condors due to nest? What's the term? Guarding nests, basically. Is there any risk of impacting? Yeah.
I am so glad you brought that up because I did not address that. It's interesting. So one of the reasons why systematic data were lacking early on was because of a very intentional approach to being as hands-off as possible on these condor nests. And I think that's a general good rule, right? You want to impact, your target species as little as possible, and particularly condors. We didn't even get into this, but the potential for culture and social learning. These are incredibly socially complex birds. We did have concerns. However, the nest failure was so high, and we had this success of some of these interventions, not only with that 2006 nest, but with some of the interventions in captivity that we were able to bring back into the field, and I should say some of those innovations were developed initially in the field. So it's this one plan approach where we're all working together. You know, when you were weighing the balance came out on careful intervention, but we built in a lot of cautions and guardrails into our programs. So for instance, you know, only a small subset of our biologists were trained to go in and nest, and they trained very hard, very intensively with the expert handlers at the zoos. And then nest entries were generally limited to no more than 15 minutes. We had certain procedures to keep the chicks calm and stress-free, or not stress-free, but to minimize any distress, any physiological distress. And so what we found was that, you know, guarding resulted in more fledging. I would also say that based on observations that the nest entries, you know, are somewhat distressing to the parents, in that it doesn't seem that parents would be more attracted to humans having had that close potential interaction with them, but not distressing enough that, for instance, it would prompt a bird to abandon the nest, or, you know. And one of the things I didn't mention was that our final nest entry of the season is always really no more than 120 days. And that is because past 120 days, the chick is developed enough and large enough and active enough that we might risk prematurely fledging the chick out of the nest if it has this human enter its nest. So yeah, so I think it's something that we take into consideration with everything we do. But overall, the effect has been a net positive. But yeah, the hope is that, again, we're able to withdraw from this intensive management and let the condors do their thing. Okay, I have another question in here by, hold on, a good question, Jenna. Is there any projection of condors being taken off the critically endangered list with their number rising? So with the current recovery plan, this would be for downlisting. And the key piece that we're really missing right now with that existing plan is the self-sustainability component. So we have enough breeding pairs. We, you know, have enough populations, we have enough birds, but we need that self-sustainability component. And that isn't to say that, you know, the plan may not be reworked. It's, you know, the plan is from 1996. So, you know, there are ongoing assessments. So I think it's still a little bit soon, but we're well on the way.
Other questions? Who's got a burning question?
Hi, I had a question. In your research, besides DDT being a large cause for concern, are there any other pesticides or agriculture runoff that might cause any detrimental effects?
I'm so glad you asked that, because I feel like I did such a whirlwind survey of the issues, and you know, there are a couple, yeah, there are some other potential challenges. One thing that some colleagues are looking into is secondary rodenticide poisoning. So they're investigating whether that might be in effect. And then another thing that I would like to mention is being intentional and thoughtful about wind energy, and you know, where it is implemented. And, you know, there are a number of different approaches that can be used so that we can potentially take advantage of wind energy, like biofencing, geofencing, right? So yeah, there are other threats, you know, and I think just like any other species, I think, you know, we'll want to keep an eye on the horizon, and understanding that some species may be more conservation dependent than others. You know, an example might be the island fox, you know, being having these distinct subspecies on small islands. I don't know that I would say that the condor is necessarily going to be that conservation dependent indefinitely. But yeah, contaminants are definitely of interest. And it's an interesting question about agricultural runoff. And I'm not sure about that. I'm not aware of any active research currently. That does not mean it's not going on. But it does remind me of some interesting results on some sea otter work, where they were finding different contaminants effects after fires in the Big Sur area versus the more human intensive Monterey area. So it was interesting because I think they were looking at population health and animal health, and you might think, oh gosh, well, Big Sur, it's a little bit more pristine, and then here you have Monterey, which has so many boats and etc. So yeah, I think it is possible. So I think that's a really good question. But yeah, secondary rodenticide poisoning is of interest.
Thank you.
Other questions? Go, Dorothy.
Estelle, is your phone number still the same?
It is. I know. I just saw you texted me. I'll text you back.
Okay,
I'm not
so
sure I'm multi-texting her.
we'll talk later. But yeah, I'll talk with you later so that way.
Awesome.
There is a question in the chat box.
Oh, yes, there is. We had Jenna King, who has microphone issues, said, is there any projection of condors being taken off the critically endangered list with their numbers rising, or is it too soon to tell?
Yeah, I think I got that one. The answer to that is we've got to get that self-sustainability piece.
Yes.
And to have that happen, we need less lead. That's really.
Estelle, I just had one question real quick. You had mentioned bringing in citizen science into your condor projects, and I wanted to ask exactly how did you go about recruiting these citizen scientists? I know that you said that they were volunteers, it sounded like.
Yes, this is actually a great question and a good reminder because we're in a bit of a transition phase post-pandemic, but there could potentially be an opportunity for any of you folks to volunteer with us. So reach out if that is of interest. Again, it's a transition phase, so I'm not quite sure where we're going to end up. We recruited in a number of different areas. So universities, we even put ads in the paper, local newsletters, in our Zoom member newsletter, which goes out to 43,000 households. So, we really just wanted anyone who had a keen interest in condors and conservation to join us. And yeah, we couldn't do it without our volunteers. They're just amazing.
Yeah, as someone who has taken advantage of a few of those types of opportunities, I have to say it is such a perfect little niche position for people because you get so much information downloaded and you get to take real part in the work. But yeah, there's not so much of maybe they don't have to necessarily go that university route. So that's very cool. I love that you guys included that.
And to have the opportunity to watch a condor chick grow up, like in the backcountry, it's just incredible. It's just incredible.
So if someone did want to get a hold of or get involved in that way, would they just go through the zoo's website or would they email you directly?
Yeah, so I'm putting my email in the chat. And then, yeah, they can, if folks are watching this, they can reach out to the zoo and ask for me, Estelle Sandhaus, and connect and we'll go from there. And then, if for some reason, it's not nest monitoring, there's also a wonderful partner organization, the Friends of the California Condor, who works with the refuge complex, and they do incredible outreach and community work. So yeah, there are a number of ways to volunteer with the Condor program. And that program has been ramping up again as well, post lockdown during the pandemic with, visits
Sure.
and stuff like that.
Awesome. Cool. Thank you. Thank you so much for sharing those resources with us.
No, great. And there's also, if the zoo is more people's speed, we have opportunities at the zoo for, animal care aides and docents. So yeah, it's kind of something for everyone, right? And I always feel like it's funny because the nest watching volunteers, it's kind of an interesting intersection of traits, because oftentimes you're hiking out in rugged areas and then you're just sitting, right? You're just sitting. So it's so some people who are really into like hiking around and stuff, they don't enjoy the quiet scope obs, and some people like the quiet scope obs, aren't as into that. But that said, we actually have, any given year, we often have nests in various distances to access, and some are literally you can observe, from the back of your truck, on the refuge. So yeah, it's there's a varied type of opportunity.
That's awesome. Well, it looks like there's already somebody in the chat too that's interested. So
That's awesome.
Yeah, that's so exciting. Cool.
I love it.
Any last call for student questions? Any students out there with burning questions?
Sorry, I got another question. I apologize. But
no, that's why I'm here. Please ask away.
So ideally, in theory, the nest guarding is only to be it would only be done until it's sustainable, and then basically back off, let them do what they want to do naturally, right? But how do you determine when it's okay to stop nest guarding? Would it be more like population, or would it be less lead poisoning? Like what's going to be the deciding factor of, all right, we're okay to leave? You
are at the heart of the matter. Yes, this is the $1 million question. And so this came about because we were able to start observing some nests fully remotely through our streaming cameras. There were some nests that we didn't enter at all in the past several years, and we were able to observe them remotely, but know that we could enter them if need be, if something on the camera were, amiss. And that's where we started to observe that these unmanaged nests, again, it's early to tell, but it looks like they may be trending towards similar success rates as the managed nests. So that's why we've decided, starting in 2020, that we're pulling back from this intensive management for a period of time. So, maybe 3 to 5 years, to see how they do, to see if this actually is a trend of unmanaged nests fledging chicks successfully. And it's such a good question because it's a very small population and it's a critically endangered species. And so, if you had a much larger population, you could subsample, you could allocate a portion of nests to be guarded and a nest to be not guarded. It's tough when you're looking at, just 6 to 10 nests a season, et cetera. So now though, we are taking that step back, and really our focus is monitoring at this time, and then we will see what the results are. And our hope is that they will be doing well, and we won't have to resume intensive guarding at that time.
Okay, thank you. Sorry.
No, it's excellent question.
Is that our last question? Anybody else want to get in before we wrap up this evening?
If you guys have more questions, shoot me an email. It's in the chat.
Can you just remind me or show me again the slide that had the live camera information on it? And there was something else that was on that slide, but I didn't catch a picture of it fast enough.
Let's see here.
That's it. Thank you. Okay, got it.
Awesome. Yeah, and I should say that the Condor Nest Cam is a collaboration between the U.S. Fish and Wildlife Service, the Santa Barbara Zoo, the Western Foundation of Vertebrate Zoology, and Cornell's Lab of Ornithology. And it's been incredible because we've had this access to Cornell's incredible audience of bird lovers. It's a dream audience. So it's been a really great collaboration.
Awesome. Well, thank you again so much, Estelle. It was such a pleasure to have you this evening. I feel like I know for sure I learned so much tonight, and I think that the rest of us did as well. And yeah, I did want to remind everybody that we do have one more speaker event for March in 2 weeks. So that comes up on the 24th of this month. It'll be Julie Matos, which I think you work with her as well. Is that right, Estelle?
Julie Matos from the park, or from
yes,
on biosecurity. Yeah.
Biosecurity. That's correct. Right. Thank you, Russ.
Biosecurity. Yeah.
Maybe not directly, but there's overlap. So that's awesome.
Yeah.
Well, thank you guys so much for having me. It was a pleasure. Thank you for all of your insightful questions and enthusiasm.
Thank you, Estelle. That was great.
Yeah, thank you. Thank you very much.
All right. Well, maybe we'll see you out in the field.
Awesome. Thanks everyone for attending and all the great questions.
Thank you.
Good night.